radioactive question applicable on this formula, whether it works or not, and this one that we've known, of which of course we have known that it has been working for you. So we are going to apply in solving this particular question that we are having on board here. So I want to see if somebody will read it for us, so that the class shouldn't be that I am the one taking the lead. So can you?
Substance has a half-life of 35 seconds.
3 seconds.
After 65
6 seconds.
After 6 seconds, the count rate was found to be 500. What is the initial count rate?
All right. Begin to bring out the data. Please, let's work it together. Let's start by the equation B there. Now, in the question, you can look at it and tell us in and this. Most of the times, if you are asked this, if you look at the question, you are finding this one here. Am I right?
Yeah.
That is the original what? Count rate, isn't it? So we don't know that. If you know the answer, you answer.
500.
Anything in the question is what? 500. Isn't it? We have 500. Then what is given to us again? We have capital T, which is what? 3 seconds. Then what again? Small t, which is given to us as 6 seconds. Are we looking at it?
Yes, sir.
So our target is to apply this formula in finding our N0. Looking at this one here, the half-life, it has, isn't it? Because this is decay constant. And in the half-life, we have something like what? Decay constant. And you also are given what? The half-life, isn't it? Yeah. We have the half-life. The half-life is given to us in the question. So for now, we can use this formula to what? Calculate the decay constant of this question. And look at it. It's going to be like this. We have the decay constant, the half-life is what? 3 seconds, isn't it? Yeah. Equals to 0.693 all over what? Lambda. And this lambda is what? Decay constant, isn't it? Yeah. Then that means if you cross multiply, you will have 3 lambda equals what? 0.693, isn't it? And your lambda will be equal to what? 0.693 divided by, and when you do this well, you have 0.231 as your what? Lambda. And this lambda is measured in what? Per second. This way. Look at this way. Do you have a question? Alright, she has a question. Don't worry, ask the question.
Okay, this particular lambda this area is second, per second. But the other one now, the velocity is equal to the lambda.
Alright, she's talking about the lambda in wavelength, isn't it? That one is wavelength. This lambda represents different quantity in physics. Here is representing decay constant, isn't it? But there is representing wavelength. Now, the question you should be asking yourself is, why is it per second? You know, when you divide both sides by this one is ordinarily supposed to be with second, isn't it? This particular one here has no unit, isn't it? Then you have a unit down here, and this unit I can write it as 1 over s, isn't it? And in this, you know that anything 1 over s is the same thing as this. Am I right? So you can see it now. Do you believe it? All right. So we have find the what? The decay constant of the particular decay rate. So what do we need now? Or why are we doing this in the first place? Who will tell me why we are doing this? Because we need lambda here. Isn't it? We need lambda. Without this lambda here, we cannot find this. So we need lambda here. That's why we go back to find what is what? Lambda. And if we know the lambda now, we can confidently what? Substitute. And when we substitute, we have 500 all over what? N naught. I hope you know where I'm going to.
Yes.
Alright? Exponential minus 0.231 multiplied by the time given, which is what? 6. Isn't it?
Yes.
And when you do it well, what will you have here? This one is going to be equals to what? Minus what? 1.386, like this. Alright? If it is 1.386 and you are sure of that, then we have 500 now all over n naught is equals to what? Exponential that. And what is exponential this? Just give me please. Exponential minus 1 point this. On your calculator, go to your calculator, you see there is a key with E, isn't it?
Yeah.
Have you seen that? Then you press that key, then you press minus 1 point what? This.
0.25.
This is 0.25. Then how can we find our n naught now? Good. You cross and then multiply. And definitely if you do that, you have your n naught. No, 0.25 n naught is equals to what? 500. And when you divide both sides by 0.25, then you have what? N naught to be equals to 2000. And when you do that, you have to have 500 divided by 0.25, and actually it's going to be what? 2000. Have you seen it?
Yes.
Have you seen it, class? Now we want to check if we can use the same formula, this one, the one up here, that we are trying to verify the validity to see whether it's true or not. Now in this question, you have your NT, which is what? What's NT? 500 divided by N naught, isn't it?
Yes.
All equals to what? 1 over 2 raised to power 6 over what? 3. Good. And when you simplify this one further, you have 1 over 2 raised to power what? 2, isn't it?
Yes.
And 1 over 2 raised to power 2 is the same thing as 1 over 4, isn't it?
Yes.
So that means we have that your 500 all over NT is equals to 1 over 4, isn't it?
Yes.
Then we cross and multiply so that you have what? N naught is equals to 4 times what? 500, or 500 times 4 is still the same thing.
Yes.
I hope you know that multiplication is commutative, isn't it?
Yes.
So when you do it well, the answer is going to be what? 2000. So class, can you see that the formula is valid and is good? It's good to go. All right. We have seen it exists and is valid, isn't it?
Yes.
So you can even go and find some of your reactive questions. You test yourself anywhere, anyhow, on net, your books, textbook past questions, and test with this formula equation A. If you see anything, find any trouble. Now, after this,